Coming up on this episode of the IoT Inc. Business Show.
If you think about blockchain as a technology that offers an integration of financial and operational execution, today in most areas of economic and business processes, transaction or the exchange of value is actually disassociated from the operational execution of that, or the interaction between products or services or people. And it's like within this gap between paying for something or saying that you will pay for something and then that something actually being delivered or executed on, that's where all of these inefficiencies lie.
Blockchain, one of the few technologies more hyped than IoT. Put them together, and it's a hype fest. But is it warranted? Honestly, I don't know. But I can tell you, for me, the decision's not going to be based on whether it's cool tech. It's going to be based on if that cool tech contributes to making more money. In this episode of the IoT Business Show, I speak with Jessica Groopman about what blockchain is and how it fits into the Internet of Things.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation Internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is for business leaders and managers employing the Internet of Things for their business or the business of their customers. I'm your host, Bruce Sinclair, and I interview the industry's leading authorities to find out how they use IoT to improve business and create value. If you like this show, subscribe to it on iTunes and go to iotinc.com to check out my complimentary articles, videos, meetups, and webinars. I just returned from Asia on a training trip, and I have to say it was quite satisfying. I love getting to know the students that attend my live programs. And although only around 5 to 10% of my business model is live training, there seems to be an appetite for it, well, at least in Asia. If you're in Asia and involved in live training, contact me if you'd like to find out more about my program, as it looks like I'll be returning. And speaking of programs, I've been hard at work at creating my online training program. I'll be making an announcement about that soon. And with that, let's get to blockchain. With me today on the IoT Show is Jessica Groopman. Jessica is industry analyst and founder at Clydo Insights, a research and advisory firm specializing in innovation strategy by analyzing new technologies' impact on humans, organizations, and society. Jessica leads the automation practice and conducts research on enterprise and consumer applications of IoT, blockchain, and artificial intelligence. Jessica and I have known each other for years, bumping into each other at various shows, so it's really nice to have you here. Jessica, welcome.
Thanks very much, Bruce. Great to be here.
Finally, we connect. So, what have you been so busy with lately?
All of the above. Certainly tons and tons of research and launching a new venture come next week. So it's been very, very busy. And expanding the scope. I've been an IoT analyst now for about 5 years, and just in the last year or so, I've really taken on a number of new technology trends. So certainly keeps me busy.
Well, I like it's interesting because we're brothers and sisters from a different mother, because I like the three, IoT, blockchain, and artificial intelligence. We're getting a little bit into artificial intelligence when we were talking in my podcast the last few episodes when I was doing digital twin. For IoT and using cognitive models, which is very cutting edge and very cool, for real time kind of simulations. But where have you seen the intersection between IoT, blockchain, and artificial intelligence? Are they pretty much separate? Or are you seeing all three of them converging in any place?
There are certainly examples of them converging, but they're more futuristic or proof of concept level than anything that's, at scale or any sort of large deployment today. We're definitely seeing lots of overlap in the IoT and blockchain space and a little bit in blockchain and artificial intelligence, potentially as a sort of way to keep AI more immutable and more explainable and grounded. But again, very, very early days for those. But that's of particular interest for me, is looking at those convergences.
So it occurs to me that you've chosen pretty much the three most hyped technologies. Is that kind of, is there some sort of a logic behind that?
It's true that, when I say that these are my coverage areas, it's true, and that I've published a tremendous amount of research on them, but I also kind of cringe a little bit because they are buzzwords. In fact, I think I saw in Gartner's hype cycle that these were the three biggest ones, and so I simultaneously felt glad about the future, but also a little sort of cringy at the buzzwordiness. So, yes. Yeah.
Well, I mean, I don't know if Gartner's publishing it this year, but they did have a separate IoT hype cycle. It was that hyped, and I'm wondering, I wouldn't be surprised if they have one for blockchain and artificial intelligence, if not now, probably coming. Yeah.
I'm sure. And, the interesting thing about all three of these is that they're kind of nothing new. I mean, blockchain is fundamentally new in a number of ways, but, M2M, ADAS systems, these have been around for decades. Artificial intelligence has gone through a lot of ups and downs over 6-7 decades. So there's something that is both new, but also really not new at all, almost a rebranding or a kind of invigoration of these topics. So,
no, it's true, and it's IoT by a different name, and that's one of the funny things with all my guests. I usually ask them, and I'll ask you, and maybe you already answered it, but when was the first time you were involved in IoT? Because the winner, by the way, was one of my guests, and he started doing IoT by a different name. I think when he was like 9 or 10 years old, building this connected pool device, I think it was. But how about yourself? How long have you been involved in IoT?
So
in all iterations, if you know what I mean.
If you will. So my journey to IoT was actually through consumer technology research. Not as much of sort of like device building DIY kind of story, but so my background as a researcher is actually in anthropology, and when I moved to Silicon Valley, I fell into what I call the technology vortex and began doing research on technologies. Started off doing very back-end enterprise warehousing systems, data management systems, and kind of clawed my way back towards the consumer side because that's just sort of my inherent interest area, and found my way to CRM, to email automation, marketing automation, social media, which led me to mobile, which led me to wearables. And then I started sort of getting this much bigger, broader picture of what it actually meant to, network connect services to sensors and devices and things. But that's sort of my weird story from a research analyst perspective, as I have been looking for, what new technologies or tools are impacting consumer behavior, consumer sentiment.
So when would you say you first came across IoT or some predecessor to it?
Oh, gosh. Probably like 6 or 7 years ago.
Okay. All right. You're a newbie then.
I'm a newbie.
Pretty much.
That's true.
Pretty much a newbie compared to some of the people on the
In the grand scheme of IoT, I'm definitely a newbie.
Now,
That's true.
explain to everybody, what does a research analyst do on a day by day basis?
Okay, so as an analyst, I conduct research on various technology markets, primarily to surface what the enablers, the opportunities are, why are these technologies relevant or happening now, as well as the challenges. What's standing in the way? What is, the bubble of hype that needs to be popped by a sober reality? Okay. So those sorts of opportunities and challenges. And then fundamentally about use cases. We hear so much about all these different technologies, but my role as an analyst is to really map out and chart out how do you actually go apply these? What does it look like on the ground and in a real world application? So from a day-to-day, I spend a lot of time conducting research. I do qualitative interviews with, stakeholders from all different realms, whether it's from a, practitioner standpoint, a C-level standpoint, legal, more relevant, developer standpoint, end users and customers, consumers. I try to, when I conduct research, sort of cast a wide net because all perspectives are really relevant when it comes to applying these. as well as, industry events where we've certainly come across each other speaking and networking, talking to people, getting a sense, again, of what companies are doing, what are some of the innovators and startups working on that everyone else will either acquire or replicate or kill off somehow. But really just getting a sense of the market and where the opportunities and risks and challenges lie and what it actually looks like on the ground.
So you do this primary research. Most of it's primary, I assume?
Correct.
Okay, and then you package it and then you sell it to, who do you sell it to then?
So it depends on the business model of various analyst firms. In my career as a research analyst, I have worked at firms that give it away for free, and I have worked at firms that put some level of it behind a paywall. So the monetization really depends on the firm. For me personally, I use research as an engine to drive whatever advisory or consulting projects I may be working on. And so, there's kind of broad general industry research to kind of build a broader understanding. And then there are specific client research projects where a client will partner with me or a research firm and really dig into a specific, market strategy or prioritization schema for features or use cases. Or something more strategic of, where do we kind of prioritize these various initiatives along a roadmap over the next few years, that sort of thing. So it takes different forms, but those are hopefully kind of a flavor.
So you put it out there, different forms like you said, but one way is you put it out there and then you'll be hired to utilize those same skills for a particular client, and that obviously would be a paid engagement then.
Exactly. And, certainly in the realm of blockchain and AI and really, frankly, all three of these, as you know, much of this is about education and just sort of conducting workshops of what this means, what it looks like, what are the data implications, the privacy implications. There's different kind of realms of considerations on consumers in the smart home versus industrial, kind of every different flavor of IoT or the whatever tech we're talking about. Has a number of elements that really need to be communicated because just, certainly if there's one innovator or change agent in a company, that's not to say that the company is off to the races with a strategy around this. So a lot of it is communication and helping illustrate what the opportunity is.
Well, why don't we dig into blockchain and, I guess I'll confess to you and everyone listening that I use these podcasts to learn. Often I'm learning it for the first time, so I'm looking forward to this discussion. So why don't we start with the basics? What is blockchain? Just take us from a ground level, either a ground level or a top down or bottom up, however you feel comfortable.
Sure. So the simplest way to characterize blockchain is as a new method of record keeping.
Okay. That sounds exciting. Super exciting.
I guess to some. It could be dry to some. But, when we talk about exchanging value, what we really are talking about is not even exchanging money or assets or votes or anything else. We're talking about record keeping. That is, I think, the very basic way of understanding what blockchain is, how to even sort of characterize it. It's a new method of record keeping. Now, the thing that we hear so much about blockchain is, and what's different about it as a record-keeping mechanism is that it's decentralized. It's a distributed ledger where financial and operational transactions are recorded across everyone in the network rather than just a single central authority. A couple of things to note when we say transactions in blockchain. I think the general mental map for transactions is around value, right? Currency, fiat, dollars, euros, whatever. But transactions in a blockchain sense, and this is where it gets really exciting, is really better thought of as events or interactions. Could be a monetary interaction, could be an identity interaction, for example, an authentication, could be a machine interaction, registering an event taking place from machine to machine, could be a vote. There's all kinds of different interactions that can be stored or ledged onto this distributed ledger. It's not just currency, but fundamentally it is a decentralized distributed ledger, a record-keeping system, where financial and operational transactions are verified by everyone on the network, not just a single authority.
Okay, so it's keeping track of transactions or interactions. Is that an accurate way of saying it?
That's an accurate way of saying it. Certainly, there's a few other things that make blockchain unique. Yes, it's distributed and decentralized. It is immutable. So in other words, in order for a transaction to take place, the verification mechanism, which is to say when all of the other, we'll call them nodes on the network, verify that a transaction takes place, that becomes immutable. Every transaction henceforth, or every future transaction, relies on that past transaction. So you can't, in other words, you can't go in and sort of, delete data. This is another fundamental difference. Every transaction relies on the transaction before it. So you can sort of think of it as a longitudinal record from that standpoint.
So, and that has implications. I mean, the one that comes to mind to me is from a security or, I guess just making sure the integrity of the data is correct. If you can't insert something in the past and you can check for that, then at least that integrity is maintained. Does that make sense? And what are the other ramifications of that?
Yeah, that's exactly right. In the blockchain realm, it's called immutability. And so, what that means is that no single entity can change the data that is stored across all of the different nodes on the network, just as I couldn't change anyone else's database. I could only change my own. So from a security standpoint, it has a number of different implications. And also within the blockchain realm, I don't want to go too deep in the technology for our purposes at this point, but what's been really interesting to see with blockchain is the technology itself emphasizes a number of sort of crypto security sub-technologies. You may have heard of smart contracts. Private and public key cryptography are inherent to the architecture. Zero knowledge proofs, another sort of cryptographic technique. Oracles, there's sort of all of these different techniques that are popping out of blockchain development that are actually very relevant to, crypto security in general. So it's sort of, it's accelerating some of those security mechanisms. And again, when we talk about lots of, or let's say, all of the relevant parties having access to this blockchain, on the one hand, you may think, oh, well, that's a replication of data. That therefore makes it less secure. But if you are, a malicious actor who's looking to hack this, effectively doing so requires that you take over 51% of the network. And that makes...
Why 51%? What am I missing here? Why 51? Wouldn't it be more than 51?
Oh, 51 is over half.
Okay, yeah.
It has to be a consensus majority, yeah.
Oh, so that's all that's required. So there only has to be over half of the nodes that are part of the network to be in agreement. Is that right? It's not 100%?
Not 100%. However, taking over 51% of a network, for example, this is the reason the Bitcoin blockchain has never been hacked, is really a computational nightmare. Not only would it be very difficult to do at scale, given that there are millions of nodes on this network, but the costs of doing so would basically outweigh whatever benefit would surely to cost more than $100 billion, which is roughly the market cap of the Bitcoin blockchain. So it sort of comes down to a cost-benefit analysis of, one, this hasn't been done before because the costs of actually penetrating it would be so high. So that's a really unique kind of element of blockchain. Another piece that I would call out that was, for me, as I was researching this technology, something of a light bulb, because I think this is a really hard technology to understand. I think the learning curve for blockchain is harder. Yeah. I always joke it makes IoT look like Toys R Us. But, if you think about blockchain as a technology that offers an integration of financial and operational execution, right? Today, in most areas of economic and business processes, transaction or the exchange of value is actually disassociated from the operational execution of that, or the interaction between products or services or people. And it's like within this gap between, paying for something or saying that you will pay for something and then that something actually being delivered or executed on, that's where all of these inefficiencies lie. For example, settlement, reconciliation, fraud, tampering, identity theft, all of these different areas where we rely on a third party to reconcile or to basically bridge this gap between financial transaction and operational execution. So again, kind of just zooming out, that's one of the fundamental value props of blockchain technology, is its ability to integrate, or at least today, significantly shorten that gap between a transaction taking place and the associated operational execution happening at the same time. To just give a quick example of this, if you think about something like post-trade settlement, and again, this is a financial use case, this is a 3 to 21 day transaction process. It takes a very long time given all of these different, credit factors that have to be reconciled between the parties. The goods have to arrive. It's a very long process, roughly T plus 21 days. In a blockchain realm, and again, we're only in sort of proof of concept and pilot mode in these kind of hyper billion-dollar industry applications, but we could get it down to 10 minutes if running on sort of a Bitcoin-like blockchain, proof of work blockchain, or even down to 1 minute, even down to 10 seconds in certain pilots. So it's, again, I'm trying to illustrate that integration between a financial transaction or exchange of value and the actual operational execution taking place. That's a really core point, I think.
So let me just try to understand it a little bit more. I'm trying to understand, inherently there is the security aspect of it. So that for sure I would think is one of the value props of blockchain. Mm-hmm. But now you're getting into efficiency, and this is what I want to get my head around. Why is it that efficient? Does it tie back to the security aspect of it, or is there something more to it that makes it more so efficient?
Oh, well, first we have to say that efficiency can be measured in many different ways. One of the efficiency major stumbling blocks for blockchain today is around power consumption. And there's a big difference in the space between a public blockchain and a private blockchain. Public blockchain, anyone can access. This is the Bitcoin blockchain. Private blockchain has very permissioned access. This is what we see being applied in enterprise markets. So, in other words, on a Bitcoin or a public blockchain, you have millions of nodes, millions of computers, often called miners in the public blockchain space, who are transacting all of the data associated with each block of transactions. Transactions are blocked, and they're called blocks. So that's not very good for the environment, and it takes a tremendous amount of computing, and the time frame that it takes is significantly longer than if you have 10, 20, 30, or 100 nodes on the network, as we would see from an enterprise standpoint. So the power consumption issue is a major drain, if you will, when we talk about efficiency, the sort of cost-benefit analysis of how efficient is this as an architecture from an enterprise standpoint. That said, when I was just talking about something like reconciliation, or to use a common consumer example, if you want to apply for a loan to, say, buy a car or a house, there are a number of different constituencies that have to sign off on various parts of that transaction, on the fact that you are you, that you have enough, an appropriate level of credit, that you have the funds you say you do, that the seller is selling you something that is legitimately theirs and can be sold. If it's real estate, for example, there's a title, there are sort of government documentations that go into this. All of these shifting parts are why we have real estate agents, why we have, local notaries, why we have all sorts of centralized services and bodies to help reconcile those. And so if you
the middleman.
Exactly. So if you think about it from that standpoint, sure, this may signal a massive job loss for entire industries of people, but that transaction process is not very efficient. And particularly when we compare it to sort of how we are now more and more accustomed on the internet to the sharing and exchange of information. You just click send and it arrives. Blockchain has been sort of coined as one of the missing layers of the internet because we don't have that equivalent mechanism for ensuring you are you and I am me, and we can sell each other or exchange value in these safe and secure ways. That's something that still largely takes place offline, or the extent to which it is digitized is only at the information level and not at the value exchange level or the identity level, or frankly what I'm trying to say is the trust level. So that's kind of another mechanism of how do we measure efficiency. to take the identity aspect as another realm of efficiency, today we have a very sort of ironically in our centralized world with centralized financial structures, government structures, the irony is our identities from an online and offline standpoint are very decentralized. We have a Facebook ID, a Google ID. We have, Bruce as the government knows Bruce. We have Bruce as the car buyer. We have sort of all of these different realms of identity, but they're not, certainly they aren't integrated and centralized to a single digital twin, if you like, for yourself. But maybe more so, we don't control that data. So again, blockchain provides a level of efficiency, and again, we're in very early mode, very much pilot and proof of concept phase for these use cases I'm talking about. But it provides a mechanism where not only can that data about any one thing, call it a person, call it a device, a machine, a transaction, etc., can be centralized, but the user itself, or in the case of IoT, the machine itself can actually control that. So that's another sort of type of efficiency.
Pause there just for a moment.
I'll pause there. I don't want to sort of...
I'm learning with everyone else listening to our conversation. So efficiency, it's funny because I was not even thinking power efficiency, so the amount of actual electricity to actually compute this. So that's something, that's an interesting topic right in itself.
It's a major issue in the AI space too.
Is that right?
Adjacent. Oh, absolutely.
Okay. But I was going more in terms of time, and what I'm trying to understand. So right now I've got a couple things that are coalescing. I've got security, I've got efficiency, I've got identity management. So I'm trying to put a circle around why blockchain. So, but explain to me again, maybe at a high level, but what makes blockchain more efficient? Is it because the records are distributed and they're not centralized? I don't know. Why is it more efficient?
Well, if you think about just a basic concept of a network, it is fundamentally more efficient because everyone on the network shares the same state of truth or version of truth. That's the idea. Today we have lots of different truths that we pay industries of middlemen to reconcile and make sure that they match up enough that we can exchange, right? So that's really, I guess, at the most basic level why blockchain is more efficient, because not only is it a shared truth, but any change to that truth is immediately broadcast to everyone, and is immutable, can't be undone, can only be transacted upon. And therefore more secure. So, some have called it a sort of mathematical breakthrough because it's really one of the first times in human history that we have a system to reliably coordinate action across parties without a central authority. It's literally, the rules are written into the code and it runs itself. It's a fundamentally autonomous technology from that standpoint. Does that help?
Mm-hmm. Mm-hmm. Yeah, no, that definitely helps. And I think now we're getting somewhere. So for me now, the state of truth or this shared truth, this seems to be key because identity management falls out of that or as a result of that, efficiency falls out of that or as a result of that, security falls out of that or as a result of that. So are we getting down to kind of the core of really where the value lies? Is it this state of truth or am I misfiring here a little bit?
No, I think at the most core level, a single version of truth is the holy grail when we talk about efficiency.
Right. And security and identity management.
And security. Absolutely. Absolutely. And especially something that can't be tampered with. I mean, I think that this comes alive a little bit more when you look at some of the specific use cases around, let's just take, for example, because this is relevant to IoT, the idea of device life cycle management. Today, a manufacturer, as I'm sure you know, some of the more sophisticated manufacturers may have a decent sense of sort of the life cycle of their devices, but it's still largely centralized. It's still largely data flowing off of that device. The extent to which that data is permissioned to anyone else may be somewhat, but there's not a sort of, this vision that we talk about for the Internet of Things is an interoperable, broad interactions between all sorts of different devices, right? Millions or billions or trillions of interactions across devices talking to each other in real time, adjusting their behavior in response to economic signals and all. Like, this doesn't exist today. It's still just a vision. So if you think about blockchain as a sort of architecture that is both scalable and interoperable to support this kind of malleable evolution of an Internet of Things, of a network, and you look at device life cycle as a way to do that, this, I think, kind of illustrates what some of the potential are. So, for example, if you have a machine to register a device that is able to register itself to the blockchain, that is able to, manage its own updates, that is able to authenticate users or authenticate other businesses that may want to interact with it for service needs. From a compliance standpoint, joint ownership, we talked about the shared economy. So suddenly a device is able to sort of take a more active role in its own life cycle, and therefore can manage the different permissions, that a single manufacturer probably wouldn't, do or even sort of tie to their own business model or enable other devices or other services. So here's an example that hopefully will help. Think about a HVAC system in your home or in a building. If this ran on a blockchain, it would be able to, using sensors, obviously understand if it's about to, go haywire, something is about to flood. It could then trigger through smart contracts a signal to, the mechanic. It could even in real time negotiate for the best deal for a mechanic to come fix it. It could also signal to the insurance company. It could also signal to a manufacturer, of course, to the end user consumer. To a distributor for different parts. Right now, this relies on very often a consumer coming home or a building manager coming to a flooded or overheated or whatever, coming home to a flooded room. The current state of resolving this kind of issue is very much reactive. And in a blockchain mechanism, not only could it be proactive, but the device could actually be sort of encoded with the rules, the legalities, and the contracts to distribute those interactions itself autonomously. So again, I'm trying to kind of illustrate this device life cycle play for blockchain because by putting this on the blockchain, we would give these devices much more kind of autonomous capabilities to act and transact and negotiate for themselves, or in this case, for, a homeowner. I'll pause there.
So in this example, just to dissect it a little bit, I think we've got two different parts. We've got the IoT technology, which does do the sensing and then does do the analytics to make these predictions that we're talking about. And then it can also then do the communication with the mechanic and tell him what's wrong, where it's wrong, what equipment he's going to need to bring, she's going to need to bring, what parts and so forth. Okay, that's all. We don't need blockchain for any of that. But where blockchain comes in, though, and I'm getting stuck on this state of truth because it seems to be holding water for me. But because there is a decentralized mechanism, and you have a shared state of truth, then this enables you to do these transactions. Right now, we could do the transactions, but we don't know if they are, legal is not the right word, but we don't know if they're the correct party on the other side. We then to actually exchange money for it, that's a whole other thing that we don't talk about in IoT. So this is a layer that goes on top of IoT, and now we're getting into the IoT stuff. But there's a layer on top of IoT that, and I guess this is where the smart contracts comes from, at least one iteration or one kind of view of this shared truth, but having smart contracts. So this means machines can communicate with other machines without having the middleman in between, and the efficiency comes out of that. It seems that you're not having to wait for someone to authenticate something or pick up the phone or agree to something because this has been set up from the beginning. There's a trusted. So IoT can make the connections, but this makes a trusted connection. Is that am I on the right track here?
Yeah, I think that's the right way to look at it. And again, going back to that financial and operational execution, if your shared state of truth which is to say all of the interactions flowing to and from a machine or a device is shared across all of the constituencies. That transaction, whether it's an event or currency exchange or, bartering power with other appliances or running safety checklists or authenticating users, whatever the interaction may be, becomes that shared truth. That's sort of the fundamental value prop.
Okay. Well, Jessica, give us a few more examples. So, what are the different ways a blockchain could fit into IoT? You've talked about your device life cycle management. Give us a few more case studies that can kind of solidify what we've been talking about up to this point.
Sure. So another case example that I came across not too long ago came out of some work that BigChainDB, they're a blockchain company, they're developing what's called CarPass. And this is kind of the same idea to centralize all information about a car to an immutable and transparent database. Right now, again, our cars, some cars have varying levels of sensor data flowing off of them. The manufacturer may leverage some of that data. The insurance company may have other data. We see a little bit of overlap between insurance and, sensor data. But broadly speaking, most of the telemetry and sensor data is distributed across manufacturer, or not really used. This is, of course, never mind mechanic data like, damages or maintenance or, registration history, inspection history, things like that. So just taking the car, there are lots of data sets that are flowing off of a single car. And so this program that they're creating called CarPass is, again, about taking all of these different data streams flowing off of a car that are owned by many different, the maintenance guy, the government, the manufacturer, the insurance company. We talk about media, things like that, and putting it onto a shared ledger. They're working with Volkswagen's financial services innovation team to sort of proof out this concept of what a car pass would look like. Again, very akin to a digital identity, as I was talking about, for a human. That's another interesting example. The French manufacturer
let me
is doing it.
Let me just sort of dig into this a little bit. So now you're surfacing another important concept, I believe, and that is, I guess blockchain would have a pretty robust mechanism for allowing data use, or for who gets to use the data.
Right.
So allowing, right? I mean, so if there is all this permissioning, exactly. So if there is all this data that's coming off, this is one of the issues right now in IoT that that we're facing, and with the GDPR that's coming up, in Europe. This seems to be a mechanism. And I don't want to fall into the hype trap too, because I feel myself, on the edge there, and sort of now being able to point pretty much anything in IoT where blockchain can help out. But certainly data permission, rights of use is a big issue, and to be able to do that on a case by case basis is pretty it's pretty time consuming. So that would be, in this particular case of the CarPass. To me, I'm thinking, okay, there's a centralization of the data, so there's efficiency there, but each data, as you were saying, are going to have different permissions associated with it for different users. What else on the CarPass? I mean, that's a big one, but what else in the CarPass is it enabling besides this mechanism to centralize or decentralize all the data on the car, and then associate the rights to use the data to whomever has the rights to use it? What else? Where's the value? What other value is coming from blockchain in this situation?
Well, there's certainly value in having all of this information in one place. I mean, just to sort of take a proxy, think about your healthcare experience where you have lots of different information about yourself, but it's in all these different databases. The same is true for a car, where if you had the entire, maintenance history, damage history, inspection history all in one place, this is obviously just more efficient from the standpoint of the integrity of the car and its life cycle, but also, there's a fair amount of fraud in this area.
Right.
And
that's where I was going to go. Yeah, this is truthful data then, right?
Truthful data. Yeah. Exactly. That again, is immune to tampering because all transactions rely on every previous transactions, that longitudinal sort of, registering of data. So that's certainly part of it. Now, we could take this, into a supply chain realm where the car is obviously relevant, but I think that's another area that's really exciting where we see IoT being applied today, often from a smart packaging standpoint. You may have heard about Walmart doing a pilot by tracking pork in China, really putting all of the different constituencies from the farm to the distributor to the retailer to even I think recyclers on this shared chain. That's another really exciting opportunity for blockchain application using sensor data that we could talk about as well.
And again, in that situation, it's a truthful chain, and it's true. And that's where I think there's efficiencies with just knowing all this information, having it in one place, but more the point is that it can't be tampered and that it's truthful, right?
Exactly. Think about something. I like to use the healthcare and the financial examples to illustrate the security and sort of the value of truth in these contexts because, fraud from an identity standpoint, these are billion-dollar industries for fraudsters. And these kinds of mechanisms would make it way more difficult, if not impossible, to, completely replicate people's identities or medical issues or, access to pharmaceuticals or even making fake pharmaceuticals. That's a whole other realm of blockchain, but is squarely focused on preventing fraud simply by the data itself being registered to the database from its moment of inception. When you are creating the drug, just to take the pharmaceutical example, and the same is true of cars or pork in China or whatever the case may be, from the sort of inception of that product to the end through its life cycle.
And knowing that it's truthful, that's where it gets to this efficiency, not the power efficiency, but the transactional efficiency or the time efficiency, because then you don't have to go through these other mechanisms for verification. And that's starting to make sense. All right, well, give us another use case. And I interrupted you, but you were going to talk about a French one, I think.
I was going to talk about, Renault, the French automaker, is doing a digitized car maintenance program, kind of similar to what Big Chain DB is working on, but really focused on maintenance and car repairs, all maintenance history in one place, regardless of the kind of mechanic or dealership that may be interacting. I do want to surface the use cases around supply chain. I talked about sort of at the product inception level of, registering a product from the time it's shipped from the farm through product development. Say if you're, putting multiple pieces together to manufacture a compliance, you can actually put each component, you can register that onto the blockchain. And again, that helps with that state of truth. If I'm building, some expensive, piece of some expensive, let's say, I was going to say a diamond, although that wouldn't have lots of components, but, luxury markets,
Sure.
Each component can actually be registered from its place of conception. So even from the product conception, product development, product distribution, you take something like pork in China, that's going to be very sensitive to temperature changes. Right now, through sensors, we may have visibility into changes of sensors, but it's much harder to identify where that, threshold was reached, or sort of what constituency, what distributor along the way may have overlooked the temperature requirements. Food safety is a really big application that we see that IBM has been working on. So distribution, trade financing, what we were talking about earlier with verifying and reconciling the exchange of money around large shipments of product, food, whatever it may be. Retail and use. The interesting thing about something like, let's take pork, is that the contents of the package can be, you can use sensors to measure the temperature and have that information constantly sent back and updated to the blockchain, shared across all peers on the chain at one time, farm, factory, distributor, retailer, processor, auditor, and eventually to the end user, themselves. And, we've seen a lot of interest around transparency of, where is this pork sourced, or is it organic, or is it fair trade, fair labor? And again, this provides a way to sort of encode that into the movement of the good, not just relying on a company sort of meaning what they say and saying what they mean, in terms of their corporate social responsibility. So certainly really interesting applications or intersections, I should say, between IoT using location data, sensor, temperature data, barometric data, whatever the case may be, for kind of preserving product integrity along the entire life cycle or movement of that good and all of the different constituencies along the way.
So if I put on my IoT goggles, so to speak, as per the show, then of course everything you said is important. But what I'm looking at is how do we make the product, the environment, or the system more efficient. It seems like it's coming down to an efficiency a value prop for IoT. Is that right? I mean, for the technology anyway. And then we can talk about I think you've been talking about the business efficiencies associated with truth. And here we're what I'm trying to get at is this really the truth in terms of transactions? So that's where the efficiency is. This really why it's so interesting to IoT at a high level? It seems like that is the efficiency from truth makes the IoT system more efficient, I guess. But also, I mean, do you know where I'm going with this? I'm just trying to now look at it from an IoT point of view. What are the benefits? So people listening to us right now, they're either deploying IoT, they're about to deploy IoT, and what their question is going through their mind is, well, how can I use blockchain? Well, we've heard some adjectives. We heard efficient, secure, truthful. It's all around that, or fill in the gaps for me, Jessica.
Well, I mean, one of the biggest issues, as you know, with blockchain or with IoT is interoperability. And so this, blockchain could provide a highly permissioned private blockchain across trusted enterprise parties. Blockchain could provide some solution to that issue. Connecting just device data is one thing, but how do you make sure that how those devices are interacting is compliant? How that data is being used. If you have, multiple sensors that are being fused to create some sort of broader picture around something, right. How can you share that data safely and securely across different partners? IoT solutions today are very expensive because of high infrastructure and maintenance costs associated with, highly centralized clouds. Right, adequate server support, networking equipment. So to some degree, there's an opportunity here around sort of sharing some of those infrastructure costs as you're relying on this shared database architecture to update and be that sort of shared truth across parties. That's a level of efficiency that's getting into more the sort of compute level, but is very relevant, especially for really, high-scale IoT implementations. Then there are, the operational and regulatory and kind of social challenges that I think IoT is still suffering from around trust. People still are not totally sold that devices can be trusted, that, do we want to rely on fully autonomous cars to drive us around, for example? So I think, to the extent that these mechanisms can be encoded where the movement of value or of, a car, for example, negotiating the fact that it needs more fuel or more electricity or energy, that's something that we are still not there in terms of kind of the current trust mechanisms. So that's another big piece. Yeah.
Yeah. Yeah. And now it's sort of, another thought I'm having is now getting down the basics for me. In IoT, all incremental values is created by transforming data into useful information. And what we're talking about here is truthful data. And I think that's the key. The value in IoT is the data. That's where the value emanates. And so if you have trusted data, that makes it more efficient and it makes it more valuable. To me, that's now it's starting to that's the high level for me from a business perspective, right? Not a technology perspective. From everyone listening right now, you're asking yourself, well, okay, how is this related to the business side? Well, if you believe that the value in IoT comes from the data, then having truthful data makes it more efficient. And, well, I guess that's what it comes down to is having truthful data makes it more efficient, makes the whole system more efficient, and therefore makes the data better, I guess cleaner, more refined, I don't know, whatever adjective. But that seems to be, this is what's sticking with me right now. Does that make sense to you?
Oh, yeah, absolutely. And, especially when we start to look at where other technologies will influence development here. 3D printing, for example, if we can, trust the fact that the designs are of structural and ownership integrity. If we look at artificial intelligence, which right now, perhaps ironically, suffers from an introspection problem. AI, particularly deep learning, is very difficult to see inside of these models and the parameters for their decision making. When you think about some of those kind of inherently opaque areas in other technology realms, and how blockchain could potentially underscore that from a data integrity or decision-making integrity standpoint, this is where we get really excited. Now, we're in very early days, and so I want to make sure that the audience stays sober, because it's still extremely early days for blockchain. There are effectively no at-scale enterprise blockchain applications to date. The market is dominated by startups and IBM and Microsoft primarily, but yeah, it's still very early days. We have to drive that home.
Yeah, no, it's still very early days, and it's ironic, but it's the efficiency component that seems to be, for the little that I know of a blockchain, it's super efficient, but then it's inefficient in the sense of kind of what you were getting at, power, but indirectly having to do all this computation, and so the resulting speed, while it may be faster than other mechanisms, it still isn't necessarily there for all mechanisms, right? And so if we look at the current state of the art with blockchain, what do you think is holding it back right now? Then did we identify that, or is there something else that's holding it back?
Many things. Let me just talk 1 second to some of the other kind of realms of trust and efficiency and cost savings in particular that we found in our research around reduced latency and increased liquidity. Again, going back to how much time is tied up in that execution process. Reducing the costs and fees associated with investigating and reconciling errors. We talked about fraud. That's a big one. Unmet compliance. Reducing labor required for processing, investigating, or reconciling, middlemen industries. Reducing regulatory penalties. This can be millions of dollars for certain industries. IT systems costs, due to, frankly, fewer systems. Users could share costs around maintenance and security. Those are just a couple of other areas that we identified as realms of cost savings that we had just sort of touched on that I wanted to get at. Now.
Yeah, no, that's important. And just to draw a bit of an analogy, what comes to my mind if data is the new oil, then blockchain with that data is more refined, right? The oil is more refined, so it requires less processing. Just to use an analogy, and if it requires less processing, that gets into the efficiency of the system. Yeah. And with IoT, as well, as well as I do, when we go into our clients and we build up the systems, we still haven't got to the major scale yet. And one of the reasons we haven't got to the major scale is this back-end processing, and is a lot, and we haven't even gotten into the legal side of things yet. But I could see there'd be a lot of efficiencies. Again, the word efficiency derived from blockchain from a legal point of view, because it's baked in, so to speak, right?
So to speak, and right question mark is the right way to think about it. Okay. Theoretically, yes. Right. Okay. You asked a moment ago about challenges, and this is one of the biggest ones. How do we get all of these disparate semi or low trusting parties to get on the same page, and not only get on the same page, but align around integration with current systems, align around permissioning and permissions testing, collaboration and buy-in around all levels of organization, from the C-level down to the ones executing and implementing maintenance programs or support programs, whatever the case may be. Writing regulation into these architectures is no easy feat. And remember, when we're talking about these new technologies, very often regulations don't exist at all. So there's that. Like, for example, around device identity. Robotic ethics is an area I've done some research in.
Right.
There's no legal precedent for that. Never mind how to write it into code, right? So governance frameworks at the operational level, at the technical level, how do you communicate this to your constituencies? We could summarize all of these various needs for collaboration as the network effect. And this, to me, is sort of the greatest challenge and the greatest opportunity of blockchain. If you think about it like a telephone system, if there's 3 nodes on the network, the value is only, there's only so much value. Right, exactly. The same is true with blockchain, where, if the entire world ran on this, we would extract tremendous efficiencies at every level. But again, to get off the ground, it's sort of this chicken and egg effect of getting all of these different constituencies to play nicely. Just as a sort of proof point, today what we see is the average number of parties involved in a blockchain proof of concept is between 5 and 7.
Okay, so pretty small.
Better than 2. Yeah. Pretty small, better than 2. Right. But we have a long way to go before, the whole supply chain runs on the blockchain, right? For even a single project or product. So the network effect in and of itself is a huge one. I think it's really important to just talk about the reputational hurdles of blockchain. Bitcoin suffers from a reputation problem. It's still associated with, the dark web, with the Silk Road underground web, with cyber criminals. It's still the number one, cryptocurrency for ransomware. And for cyber criminality, cyber penetration. There's also a sort of language issue. There are different, I made a list somewhere of distributed ledger technologies, blockchain, chain of blocks. It was something like 15 different names for a blockchain, and, the preferred term dependent on who you were talking to. In the public blockchain space, there's a whole lexicon. In the private blockchain space, it's a whole different lexicon. So some of it is just sort of very simple, like language issues to properly communicate about what it is. And this, of course, gets swallowed up in a lot of the hype that we see online and at conferences and everywhere else. Another thing.
But a lot of what you're talking about right now, though, can be attributed just to the early stage of the technology, right? I mean, it's still early days, and so what's going to be clear? It's not going to be the interoperability issues is the big one that you're talking about. Just the clarity of what it is, the trust, and so forth. All these things can be attributed, I think, to the amount of time that it's been out there and being used. That's going to go over time. But I guess, if you were to give advice to people listening right now, I'd be asking for 2 types of advice. Is this something that people, well, first of all, it's going to be a 2-part question. Where should everyone that's listening right now start their investigation into blockchain? And then secondly, is this something that's on their 1-year plan, their 3-year plan, their 5-year plan, or their 10-year plan? I mean, I guess what I'm really asking is this something to worry our pretty heads about right now, or do we want to let this sort of develop a little while before putting our own energy into it?
The answer is sort of both, and I'll talk through that. I think, as we forecasted this space, the research I produced on this with Tractica, we actually did a 10-year forecast for blockchain enterprise applications. And, after consulting with the team, really I did not want to say more than or earlier than a 7 to 10-year time frame. There are just so many elements that have to come together that it's hard to see how, blockchain will take off in 1 year. It's inherently not a technology or an initiative that any single company, even the Googles or Amazons or Baidus of the world, could lead. Okay. It is inherently requires, again, that network for value. The other piece of that is there's this philosophical difference in the blockchain space that may or may not be overcome in sort of a fragmented way. On the one side, the birth of blockchain is in some ways sort of this anarchist view where we want to move away from centralized bodies. We want to move away from centralized control. And that characterizes the Bitcoin and the public blockchain architectures. Anyone can join. It's akin to, having a soccer field with no rules, no referees. Anyone on the stands can jump in and start playing. Meanwhile, over in enterprise space, it's highly permissioned, and highly, who can access what at what times and what amount of data and how that is secured and where it is stored on or off the chain. These various things, this is a fundamentally different philosophy around blockchain development that could very well split into fundamentally different camps and perhaps even different technologies or different names for those technologies. So again, the sort of decentralized, flat organizational structure versus what historically, from a sociological and financial standpoint is the mode that we operate in, very centralized on the side of corporates and governments. This is one of the reasons that we see financial services and governments world over as being the top investors in blockchain. They arguably have the biggest disruption coming. So, in terms of how to get started, I think the earlier that business leaders and innovators can begin to educate themselves on what is blockchain, as we've probably suffered through today, it's hard to really talk through these questions. It's a fundamentally different way of organizing data and business value and transactions, and the role of an end user identity and the role of a machine identity. So really wrapping one's mind around these broader issues, and also in very specific areas, I think, around the technology, around the security, as well as the regulatory hurdles. There's no better time to start with that. And certainly, more and more companies are piloting in terms of how to get started. You can go all over the internet. IBM, for example, has, developer forums where you can literally try out, you can build a small application on blockchain today. There's certainly ways to begin sort of dipping one's toe in these initiatives. The number one kind of recommendation that I give, again, just given the inherent nature of blockchain, is to look for consortia. We've seen this rise of industry consortia in blockchain who are really leading and thinking through those regulatory hurdles, those technical hurdles, to...
And what are some examples of the consortium?
Well, in fact, there's one called the Blockchain Iot Consortium, highly relevant to this audience.
Okay.
That's a big one. They launched, I believe, 6 months ago now. Okay. The Hyperledger project is probably the biggest and maybe most visible. That is across many different industries. They're really focused on enterprise use cases and have done a lot. They're closely tied with the Linux Foundation as well as IBM, so they're doing a lot around supply chain and some autonomous car work. On the financial side, there's one called R3, who has their own protocol called Corda. But there are others. I've heard of consortia specifically for real estate, for insurance.
No, but I like this approach because it kind of separates the noise from the signal from the noise, because the consortia generally they're coming together for a purpose. And one, obviously, the Blockchain Iot Consortium would be highly relevant, but the Hyperledger one I think is somewhere to look at. And I guess my advice, and then you correct me where I'm wrong, is number one, for everyone listening, stay informed, and we are gonna be doing a number of more interviews on blockchain, getting into more of the tech, getting into more of the business side. So stay informed, but. And I think you just gave a really good way to do that. I'm sure there's tons of sources on the internet. You can Google it, but I like the consortia just because, again, of their focused nature. So stay informed, maybe use the consortia to do that. However, the timeline here, I certainly wouldn't be architecting, or I certainly wouldn't be waiting on blockchain in any way or form to move forward with IoT in business. It's just too far out there.
Right.
But again, and I'm even thinking, I was thinking, well, then is there an architecture, is there a specific architecture that you could mimic, or not mimic, but that you could take that would future-proof you? But if it's a 7 and 10 year time frame, it doesn't much matter because you're going to be going through a cycle of technology, at least 1 or 2 cycles of technology anyway. So I don't know. Does that sound like a reasonable advice, or how would you change that advice?
Well, I mean, what's the quote of we always overestimate the impact of technology in a year and underestimate in 10 years? Maybe I'm getting that wrong. But, the point being that 7 to 10 years, the entire world will likely look very differently. So, from the standpoint of current trajectory, current lack of standards, the inherent shared nature of blockchain and how fundamentally different that is culturally of most of our governing and economic structures, those seem like longer-term time frames from a business adoption standpoint. Now, that said, I see in this market some really big enablers. Autonomous cars, for example. This is a technology that is not here today quite, but accelerating very, very rapidly. And then would sort of produce a precedent for what that would look like for a sort of shared both autonomous or smart cars and autonomous cars and regular driving. These things don't happen overnight, but once we start to see the kind of introduction of these net new categories, I see big acceleration in blockchain. The other thing that we haven't talked about at all today is some of the applications for blockchain that don't involve devices, but again could be accelerated, as certain industries adopt blockchain. Just to use a very quick example with autonomous cars, there's a whole realm of blockchain around digital rights management and what that means for advertisers and how, content itself can be ledged onto a blockchain. Right. So, just to say to the audience, keep your eye on some of the other trends that may accelerate quickly and then would sort of give an open door to blockchain for that specific industry. That's what I would add.
Yeah. No, I think that's good advice. And it's be informed, you have to be informed on blockchain. It may happen quicker, in different industries than what we're talking about here. But, if you're trying to make money with IoT, which is what we're all about, then in the short term anyway, be knowledgeable about blockchain, but certainly don't hold anything up. At the same time, I think what's useful for blockchain is looking at what it does. And again, we're talking about it from an IoT perspective, but what it does for IoT, and then reverse engineer that, because what it does for IoT means today, without blockchain, you're going to have another mechanism to do this. And so it's an interesting, I think it'd be an interesting mental exercise to kind of go through, the value the blockchain has to IoT, and then, okay, we don't have it, so how do we implement it without it? And so each one of these different areas that we've been talking about, all related around, I think, this shared truth mechanism, takes a bit of work, and when you get the scale, that's when the rubber really meets the road.
Yeah, certainly some of the pilots that we're seeing today will focus on, a single product line, as in the case of Pork and Walmart, or a single regulation, looking at this specific type of KYC compliance or AML compliance, for example. So that's, I think, a good place to start to sort of get your hands wet, to figure out some of the ahas along the way, but, not necessarily scale fully until you have gone through some of those hurdles.
Yeah, no, that's good advice. All right, Jessica, where can people find out more about you and your company?
So you can reach us at www.kaleidoinsights.com. That's Kaleido as in kaleidoscope, Kaleido, insights.com. And you can find us on Twitter at Kaleido Insights and on LinkedIn. Please feel free to reach out. We'd love to talk.
Excellent. Well, I'll put all that in the show notes. And with that, I'd like to thank you. I think we accomplished what we kind of set out to do. It's high level, but I certainly got a lot from our conversation. I'm sure everyone listening did as well. So thanks for being on the show.
Very good. Thank you, Bruce. It's great talking to you.
Okay. Well, that was episode 92. 2s and a 23. So I'm not really sure about that number. To get an analysis of this episode, links to things that were mentioned in the show, plus the full transcript, go to the show analysis notes. Each podcast has one, and they can all be found at iot-inc.com/podcasts. And if you sign in with the long form and get access to the private reserve, you'll have access to all the transcripts from all the podcasts and all the videos I've created. If you've been enjoying this podcast, subscribe to it. That way you'll get an episode delivered to your device every time a new one's released. And there are 3 ways you can support this podcast. You can share it on your blog, personal or company, if you think others will find it of value. You can share it on social by going to the show analysis notes, and there's some widgets there. You can click, either going to be on the left or the bottom of the page. And you can leave a rating or a review on iTunes. I'm trying to get to the 100 mark. So far, 77 I think it is. In any case, go to iot-inc.com/iTunes/. That'll give you directions of how to leave a review. And it's really easy. It's either just one click or a little bit longer if you want to write your thoughts. I'm your host, Bruce Sinclair. Thank you for listening. Until next time, may your path to IoT business be a truthful one.
You have been listening to the IoT Inc. Business Show.